All right, we're going back in on that Dr. Z MAZ 18. We're going to change out that noisy 68K carbon composite plate resistor. And I'm going to show the difference between how Dr. Z wires these and true military spec, and why true military spec is vastly preferred, rather. Kind of trying to do this with the work on the other side of the phone from me, so it's a little bit awkward. Again, I get the worst of the solder out first so that we can see what we're dealing with. That's almost as much as I can get out with a solder pump, the solder sucker. So we can hear some braid. Try to do this without burning myself or the phone. There it goes. This turret had 3 components around it. That capacitor, the leads for the resistor in question, and this wire up top. I already removed this before I started. Let's see if I can see this to show you guys. I'm trying to look through the lens. The lead for this resistor was wrapped multiple times around this post. And mil spec is you never do a full wrap, you do a U. About 180 to 270 degrees, but not 360 or more, because it makes it really hard to do field repairs. Mil spec is designed to make things very reliable and very rugged, but to be field repairable. For some reason, the military likes to be able to fix things quickly. So there's a lot of talk about mil spec amp builds. Most are not mil spec. I would be much better at doing this if I wasn't filming this. I can barely see what I'm doing as I'm doing this. I need new glasses. Okay, got those separated. So here's the lead from the capacitor. Notice all that extra length. And here's the lead from the resistor. And I'm gonna get in here on the turret, get that old excess solder out so that when I wrap the leads again, rewrap the leads on the capacitor and the leads of the new resistor, I'll have good metal to metal contact before any solder is added to the mix. I'll also get that flex off the board here and clean it, but I'll show that in a moment. Let me get the other end of this resistor the same way. I got it off here. So I'm going to pause this because I have to move the camera. I'm sorry, I just can't do this with the camera here. Okay, got it out. Got the old solder out. Cleaned up all the old flex on the board. Here's the old 68K resistor with its very long leads that were wrapped multiple times. Besides it being difficult to unwrap all those leads when it's wrapped multiple times beneath the solder, it also means you have to heat things up a lot more to get all that loose. And all this stuff bubbled out of this resistor as it got hot. Now, if I had to use this resistor, or as a part for a satellite or something, I would have used some heat sink methods to keep the center body from getting so hot. But even better than having to do that is not have all these excess leads to begin with. So on this capacitor here, I'm going to straighten this out. A lot of this wire is going to be snipped because it's only going to have a partial wrap in the future, but I want to kind of straighten it out so when I do that bend, it'll be easy. Let me get another 68K resistor in place first. Okay, we're going to use this 1 watt carbon film, 1 watt carbon film, which will be quieter than that old 1 watt carbon composite. And I'm just kind of showing myself where the bends will be, because there's not a lot of room in here. And again, it's a bit trickier to do when the camera's in place. So this tells me there's going to be a bend here. Help get this to focus better on us, on what we're doing. And there's going to be a bend here. So I just want that kind of loose right now. I'll put it back where it goes. I want this at the bottom. It's a little bit tricky to get to line up the first time. All right. Now here's the crucial bit. Let's see if I can get this to focus again. I don't want a full wrap. I want just a U. And I want it to just begin, come back on itself. And that's all it's going to take. And the excess will get trimmed off. We'll do the same thing on this side. Someone asked if they could see me doing some more of the soldering stuff, and so I try, but it is rather difficult to do this stuff with the camera where it needs to be versus where I need to be. I snip off some of the excess. Let's see, I'm looking through the lens because I can't see it otherwise. I just want to crimp that a little bit better before I snip anything. Get in here. A little bit of excess I will fish out in a moment. All right, now I've got partial wrap on either one. It's not full, it does not need to be. Now I'll solder the far one because it has all its leads on it. So I heat it up, bring a little bit of solder to the heated component, let it flow. I just want to have a fillet of solder in there. No big blob, just enough to secure everything further and to keep oxygen out of that metal-to-metal contact. Now this one, I'm not going to solder until I get the new capacitor lead wrapped. So I bring that around itself. But again, I don't want it to be a 360 or more degree wrap. Just need it to be a U, which is kind of firmly held in place against the post. And if anyone ever needs to change this resistor or cap in the future, they will thank me for this. Now I'm doing this left-handed while looking through the camera lens. So again, I'm usually much faster at this stuff, but it is difficult to do this while filming. So bear with me. Now I've got those two leads where they need to be. And again, heat first, then bring the solder to the work, to the heated work. And doesn't take a ton to get a nice, clean, reliable solder joint. Make sure I didn't miss anything. Maybe a little bit more for luck. Right here on the back. All right. Those are reliably connected leads. Now this, ironically, was the factory lead connection on this wire, which was not a 360, was barely even 90. So I've got a little bit of slack. I'm going to give it some more, expose a little more wire so I can do a proper wrap on that connection. The one wire that the factory did not use excessive links on. Let's see if I can get some of that old solder off so the jacket will come off. All right, good. Did it without nicking the wire. So bring that up there. A little bit of corrosion on it. Let me tin it. little more tinning. There's a brown spot there where it oxidized over the years. That's gonna be better. Yes, that stuff matters. All of this matters. Now, tinning it makes this wire a little bit stiffer, but not too bad. And again, I want that partial wrap. 270 or just a hair over. Snip the excess. Sure, it'd be easier to do without the camera here, but then you couldn't see what I'm talking about. I never have any assurance in life that anyone knows what I'm talking about, so I should just get over it. I have to move the camera to get this snip done. Sorry. Okay. Now that that is mechanically in place, I will do the same solder technique. Make sure the solder is flowing between the wire and the post. Sometimes it wants to pull out when it gets hot. That's no big deal, because I can put it right back in there and get that mechanical connection. I said I can get it right back in there and get that mechanical connection. It doesn't want to cooperate because I'm filming it. There it goes. All right. Notice you can see all the individual wires beneath the solder. And there's one little snippet there I could have trimmed a little bit closer, but I had the camera in the way. It doesn't matter. This is actually what you want to see. You want to be able to see the wire beneath the solder, but have no gaps. And everything neat up on against itself, very clean and shiny. This is going to be a very reliable set of connections. And it will be every bit as rugged as the factory stuff with the multiple wraps, but it will be much easier to service in the future, and there'll be a lot less heat involved in the process. So that does it for this bit. I think I'm just going to call this video done at about 15 minutes. Be a little bit less after I edit it. But the next thing to do is to see why the reverb tank is humming when it's in proximity to the chassis. See if any shielding can help, or maybe it's just that the RCA jacks need to be on the other side. Reverb tank positioning can be a weird thing, but we'll get to that next. All right, we're back with that Dr. Z MAZ 18 with the hum and the reverb. Ignore the clutter on the desk. Clutter is a sign of a good mind. It's like never eat food made by a skinny chef. All right, here's the issue. But watch this. It's not just upside down, it's having the inputs here that's so noisy. That's the orientation that it was as it came in. If I reverse this, so the input jacks are to the front, that noise is greatly diminished. This is the quietest orientation. This is how it is in the amp. This is the quieter orientation, even with that up against that transformer. I'm not sure if there's quite room to do that because of the way the transformer is. No, there's not, because the thickness of the front panel. If it were here, no problem. Where it needs to be, minor problem. There's just not a lot of room inside that chassis. Inside the cabinet, rather. If we're like this, it'd be in the null. That would be ideal, but there's not room. I wonder if I could move this output transformer back half an inch. Anyway, there's a reason a lot of heads don't have reverb. Well, I will sort out that reverb issue in a little bit. The noise floor is greatly diminished now that that plate resistor has been changed out. There's still a little bit higher noise floor than I would like. Part of that is to do with the way Dr. Z incorporates the mix resistor for the reverb and this 12 meg local negative feedback resistor, which is not a lot of negative feedback, but a 12 meg resistor is a great place to introduce noise. So I'm going to go through here and mute grids until I can isolate where that noise is coming from. But all that said, the amp is sounding pretty good. This is with SG. I was talking about that master volume, the stock one in the Mark I, cleaning things up with it low. Back up where it should be. So that's a big strike against the Mark I master volume. I've got a new dual gang pot arriving to get that going right. Sorry, that feedback. I'm standing too close to the amp to have it that high a volume. Make sure that it's not an oscillation in the circuit. I'm not going to play it like this, but with treble middle bass and all the volumes on 10, it is stable, so that's good. Put this back down to some sane stuff, and play this out. So we are getting there.